Okay, welcome back to the internship video series about is it food safe, can it be sanitized, how do things work? I mean, it's threefold about what's going on here. This has been a huge undertaking for me and my group that I've spearheaded, and it's been awesome. So, last time we reviewed how things work, viruses, bacteria, particle sizes, filtration tests, some of the math used. And you're probably wondering, well, how the heck does that relate to sanitizing 3D printed parts? It does. It really does. The streamline functions and particle diffusion and Brownian motion has a lot to do with sanitizing. I know that sounds weird, but it does. I mean, at the microscopic level, you have fluids like your cleansing agents. How are particles reacting in that? How are things working in that? Soapy water and surface tension, rubbing alcohol and surface tension. We went over that. So, and then, but how does that work with filtration and masks, and why does that go into food safety? Well, mainly because it all started with COVID and people printing masks and face shields and being worried, can it be sanitized? And that's how masks came into this. But then there's also been a lot of issues with people not understanding how masks work because they don't understand how viruses work. So I had to go into that into the internship so that people could understand. Now, we've known for hundreds of years how they work, but the reason why I chose in my internship to reprove it and reinvent the wheel is because I'm trying to help educate people so they can make their own choices. But it all relates to food safety because of how particles work and how things float around. Okay, let's get into preliminary testing. This is the surface and gap testing. This is where I used a lot of petri dishes to test tons of things. And like I said last time, this petri dish right here is perfect. Whoever made this did an excellent job. When you culture bacteria or whatever you want to do, you first take a little sample on your eye hook. It's like think of a wand, and at the end of the wand is a little piece of wire with a little round ring. And this ring hook, you dip it in broth or from another culture, and you spread it around right here in this quadrant. And then you take the same ring hook and then you move it around back and forth into this, from this quadrant to this one, but you only cross the boundary 3 times, and then you just smooth out what you had, and then you do it again here, and that way you can dilute your bacteria. So you have different dilution rates, or I don't want to say dilution rates, but different dilutions of your bacteria. It just makes it easier to control and better. So, moving forward, for the first set of the tests, I used petri dishes to culture bacteria on 3D printed parts before and after washing. I also tested many other items such as my shirt, fingernails, after washing them an hour previous, a glass bowl, a metal spoon, and a cotton mask. Each item was swabbed with a sterile swab, then properly cultured on the plates. I then cleaned a section of each item with rubbing alcohol and soapy water using regular Dawn. So think of a 3D printed part. It has 2 sections. I cleaned one with rubbing alcohol, one section with rubbing alcohol, and one section with soapy water, being sure not to allow rubbing alcohol to flow over to the one side and vice versa. So I mean, think of like little squares, and they were both equally as dirty because of being handled and everything. So I allowed the bacteria to grow for 4 to 5 days in a 75-degree controlled environment. And I mean, the 3D printed parts I left out for 6 months. I mean, I had been touching them, I had been putting them on my face, I had been doing things to ensure that they were dirty. I had breathed on them, I had licked them, I had done, they were nasty. So, now, the results are exactly what I suspected when I swabbed them, really dirty petri dishes. And then when I cleaned them, I was actually pleasantly surprised to see how well soapy water competed with rubbing alcohol. it was definitely below what we call the infectious disease number. So each bacteria has what they call an infectious disease number, and there's a mathematical formula to figure out how much bacteria you have, how much has been reduced, and if it's considered an infectious disease. If you ingest a certain amount of bacteria, you can get sick, but if you're below that number, you won't get sick. So it's knowing that information as well. Viruses work the same way. You can breathe in a certain amount of infected host cells and not get sick. So there is a threshold, but also your immune system. It all depends. There's so many variables as well. So, like I said on this, I used more than 40 petri dishes just for swabbing on surface tests. This is not a fly-by-night experiment. I also know how to make my own petri dishes in a sterile environment. This was all done under the flame, and what that means is we have a Bunsen burner, and you do it under the flame because that heat pushes contamination up and away from your petri dishes so that you can keep your petri dishes open under the flame without being contaminated. And each time you use a broth of bacteria, you have to heat up the tip of the beaker for about 3 seconds so that there's heat and convection, so contamination from the air doesn't go inside the bottle. So it's kind of cool. Petri dishes, again, are the gold standard for testing and culturing. Whenever possible, always use a petri dish to test. Your data and your results are going to be far better. So let's look at some pictures. Okay, from left to right. The very far left one is my fingernails. Now, this is after using the bathroom and washing my hands, and this is an hour later. Not doing anything crazy. I didn't go play in the dirt or go do something else. This is just everyday things. I did some homework, maybe ate some food, but I hadn't washed my hands for an hour. And this is what grew on my fingernails. Okay, then the 3D printed part is, let's look at this one. This one's a 3D printed part. And in fact, that was actually my 3D printed mask on the, let's see, was this the outside or the inside? This was the outside. This was the outside of the mask. It was nasty because I hadn't worn it for a while, and I was just sitting there and just chilling. But I'd made sure to always mess with it and get it really dirty so I could see what was growing on it. Okay. This one is really interesting. I had a really cool Hawaiian shirt, washed it, put it on, wore it for 8 hours, and then I swabbed the front of the shirt. And this is what grew on it after it had been washed. I mean, that is crazy. And fun fact, there's actually 10 deadly pathogens found on that, but most of them live in your trachea anyway and your GI system that we just breathe out. But they're all well below the infectious disease number, so it doesn't matter. But yeah, 10 deadly pathogens found on that right there. Isn't that crazy? So if you were to test an actual cotton mask, you'd find 10, even maybe more, maybe even 20 deadly pathogens on your mask, but it's well below the infectious disease number. Okay. This one is a metal spoon that had been sitting in the drawer for a few days after it had been washed in the dishwasher. Was it dishwasher? Yes, dishwasher. So it's just sitting in the drawer. Whatever. That's all it's doing. So, those are the pictures of what they look like before they were cleaned. Now this is the results after. The first image on the left is a 3D printed part, my mask. This was cleaned with 70% rubbing alcohol. So it did pretty well. The middle image is the same part, the mask, cleaned with soapy water on another side. Well, okay, so what I did was I washed the entire mask in soapy water because I'd already done the alcohol swab. And then I made sure to swab the side that didn't have any alcohol on it. So this is with regular Dawn. I think 115 degree tap water. So pretty decent. Just warm water. And I mean, it did really well. Okay, and then the last image on the right is the metal spoon with soapy water. So you can see not really too much of a difference between a 3D printed part and a metal spoon. It's very similar. So they actually had pretty close to the same number of colonies when he did the math, and there's a mathematical formula to determine that. But again, it's well below the infectious disease number. So when it comes to actually sanitizing and cleaning, you can sanitize and clean a 3D printed part, no problem. Like I said, soap and rubbing alcohol gets into places small and as small or smaller than viruses. So it can be cleaned and sanitized, no issue. And that's with regular PLA. And so it can be sanitized. It's been proven so far right now that it can be sanitized, no issue. But we will get into SEM images of 3D printed parts to see how solid they are and to see if there's any concern with that. But I mean, if you look at this spoon compared to 3D printed part, I mean, the same amount of bacteria. It's really not an issue. Where our problem, what we want to do is now test something called biofilms, which is if we agitate and stress out the bacteria and they produce a biofilm, that's like a blanket. Think of this shield or a cloak that you put over that gives you warmth, it gives you protection from the elements and poisons, and it also gives you food. That is what a biofilm is. So that's our next goal, is to see how well we can clean a biofilm from a 3D printed part. And not a lot of foodborne bacteria or illnesses come from biofilms. There's not any bacteria in the food area that create biofilms, but there is in respiratory situations. So, where does this take us next? This is going to take us next into a section with scanning electron microscope and looking at images. And we're going to talk about how solid 3D printed parts are, the pores, the dimples, how well can they hold water, all of these things. Because food safety is not about just sanitation. You've got to look at what's the material made of. Is there toxins in the material when it's printed that can hurt us? Or is there enough that's even going to matter? I mean, you have a brass nozzle. Brass has lead in it. Is there enough lead contamination? We got to start looking at other things. And so this is where it's going to go from here. So that's going to be the next set of videos. So thank you for watching this one today. This one was shorter, which I'm glad. So just stay tuned for the next set of videos.